Thank you, Jessica, for the introduction. Hi, everyone. Great to be here. Thank you for inviting me, and I'm very excited to talk to you all about some of our most recent work. And since Jessica mentioned interdisciplinary and cognitive psychology, I want to start with a really quick demo that our visual system is very powerful. And here is a demonstration to kind of make us feel that. Okay, so I have a table of numbers, and you have maybe 3 seconds to figure out what pattern is in this table of numbers. Count to 3. That's about it. Surely you've got it. No, you didn't. Nor did I, right? This is very, very difficult when we just throw arrays of number at people without allowing people to leverage the power of our visual perceptual system. What if I do this? I now added a color layer where the darker color correlates with a higher numerical value. And suddenly your visual system is able to pick up that the numbers on the diagonals are associated with the darker purple, and thus it's higher in value, right? The pattern in this became super salient to you because our visual system is very powerful. So I study data visualizations, and it's a whole field that focuses on how we can leverage the power of a visual system to make sense of patterns in data so we can better reason about data. And specifically, I try to interface between the visualization folks and the psychology folks, and I'm here to talk to you about series of stuff that we've done at the intersection. And if there's anything I want you to take home today, that is this message here about design. So design choices, they're very, very important. They can lead to very powerful insights when you're using them correctly, but when used poorly, they can obstruct patterns in data and make us misunderstand data. So since I'm in Georgia, I have an example about Georgia. So this is a visualization created by the Georgia Department of Public Health. Okay, it's a government agency, and they hope to communicate COVID-related patterns to their regular citizens in the constituent. So here is COVID data about 5 counties in Georgia. What do you see upon looking at this visualization? What is the most intuitive takeaway upon looking at this? Maybe something like the data trend is decreasing, right? Which is what we all see here. But then if you were to stare at this for another 10 minutes, you'll realize that the dates here are not ordered. This downward trend is misleading. You see that there's April 28th on the left and May 9th on the right. And in the middle, there's like April 26th here, and there's May 4th here. Why did the Georgia Department of Public Health do this? So they didn't do this to mislead. Okay? They don't want to mislead people to think that COVID is getting better. What they wanted to do is they wanted to tell you on which day there were the most number of cases and on which day there were the least number of cases. But that intention did not manifest here well, right? Everyone see this really salient misleading trend. So to kind of think about ways we can redesign this visualization, we did this. So instead of not ordering the x-axis by time, we did order the x-axis by time, and we sorted the data by county. And now you can see that there is a slight downward trend, but the trend is more like bimodally distributed. So it's not a strict decreasing trend. So here, we are seeing that it's easier to see the change in COVID cases across counties. You don't see that big misleading trend anymore. But if I were to ask you, looking at this, on which day there were the most versus least number of COVID cases in Georgia, it's going to be very difficult for you to tell because you'll have to pick the bars and then sum them across different sets of bars. And that's really difficult, right? So that original visualization does work for that task. It just does not align with what people intuitively do. And it caused a lot of miscommunication in Georgia because of it, right? So what I'm trying to say with this example is that it seems really easy for me to critique visualization post hoc, but the process of creating that visualization can be somewhat complicated, right? You have some data, and some data scientists have to analyze the data to visualize it so that some information consumer can then interact with the data to make sense of it through some interpretation. But that process is not linear like this. It's more like branched, because depending on how you design your visualization, like we've seen with the COVID example, people will have different interpretations. And so I use this I talk about decisions as when you design a visualization, you can make decisions about how you want to group colors and how you group bars or order the x-axis. And all these seemingly small design decisions, they can have a different downstream impact on people's interpretations of the data. So here I have another example to show you just small design decisions can have large downstream impact. So let's imagine this world. This is the reality in this world where we have 4 groups of people of different colors. There's purple people and green people, and they make different amounts of money, right? They make different amounts of income. And you take this reality and you visualize it using something that we all see every day, which is simple bar charts to show the average income by these people with different colors. This is very common, but when you do this, when you visualize people's income using a bar chart showing their average, what happens when the person reads this visualization is that they're going to think that every purple person makes more money than every blue person makes more money than every green person. They're going to form some kind of group-based stereotypical inference of what actually happens in our world. And you can see that people's inference here does not really reflect reality here. Right? So this visualization is fueling these stereotypical responses from people. So what can we do to combat this so that people don't make these stereotypical attributions? And what we do instead is that we can create a jitter plot where instead of showing aggregated mean values of people's income, you show the dispersion and you show the variability in data so that it corresponds more to what happens in reality. And just this one simple manipulation to show uncertainty or to show variability in data, what you see is that upon looking at this jitter plot visualizations, people no longer make those stereotypical conclusions that every purple person made more money than every green person. They start to realize, okay, even though on average purple people make more money than green people, that is not the case for every purple person and every green person. There's variability, and it doesn't mean that purple people are better than green people. So what my research program kind of tries to do is we try to understand the relationship between design and interpretation. And this design space is very large, right? You can imagine there are so many design decisions you can do. So we can do this research for a long time. And we're building slowly towards a more consolidated model where we can input a visualization and it can output some kind of design or it can understand what the visualization is trying to say to predict what people will take away from the visualization, how they will interpret the visualization. Let's give you another example here. So imagine this model works. Let's say we already finished my career and we're done. And what this model will be able to do is you give it a visualization like this. The model will say something like, people looking at this visualization will be utterly confused because they have no idea what you're trying to say. So they will give you some suggestions to improve your visualization. So you redesign it to look like this. And on the top there is as how people get their news, and there's a bunch of sources like television, radio, and newspaper. And you feed this visualization into your model to ask it, how will people interpret this visualization that I revised? And your model will hopefully say, upon looking at this visualization, your audience will most likely conclude this conclusion. People mostly get their news from TV and radio, least likely from their friends. This is based on research from visual saliency. We know that people like to look at the title and they like to look at the top kind of row of your visualization. They kind of ignore the rest, right? So that is a correct interpretation of your visualization, and it is what people will say upon looking at this, but it's not quite what you want to communicate just yet. So you want to maybe iterate on this visualization to make it better. So you do this. You highlight this line that represents the relationship between news source and internet. How often people get their news from the internet. And you feed this visualization to people, and the model will predict that people looking at this are going to conclude people are increasingly relying on the internet to get their news, which is what you had in mind. So that's kind of how we envision this model that is able to take visualization design and predict human interpretation to help people design and refine their visualization better. So we ask the question now that we have large language models, state-of-the-art, very powerful AI tools out there. How well can they do this at this moment? How well can we feed a visualization to the model? How well can the model predict viewer takeaways from visualizations? So we tried that. And we're going to take a closer look at some of the GPT takeaways. So the short answer I have for you is GPT kind of doesn't do very well. And the long answer is it's not, they don't do well, not quite because of what you commonly hear about hallucinations and inaccurate information, but they just they don't operate the same way as humans. So they don't serve as good proxies, and we shouldn't treat them like so. And to kind of have us feel it, if you were to look at this simple visualization showing the price of two drinks, or three drinks, drink 1, 2, 3, across two bars, bar A and bar B, what data elements do you want to compare upon looking at this visualization? Yes. The bars vertically, right? You might want to compare, let's say, the price of drink 2 in bar A to bar B, or the price of drink 1 in bar A and bar B, and you say, okay, drink 1 is about the same 2 bars, and drink 2 is much cheaper in bar B, something like that, right? That's what we want to do intuitively. But what GPT likes to do is something even, it's not incorrect, but it will say, I'm looking at drink 1, and I noticed that drink 1 is more expensive than drink 2 and 3 in bar B. It would even say things that's more complicated, like across all 6 drinks, drink 2 in bar B is the cheapest drink, which are all factually accurate, but they're not something that we would intuitively know. So what this really reveals underneath is that state-of-the-art LLMs, they struggle to generate these semantically diverse and accurate takeaways from visualizations in the sense that they are not sensitive to design the way that humans are sensitive to design. So when you show these 4 visualizations with different simple design layouts, they're all the same. Like one is stacked and one is adjacent. You just take that and you move it there. These are all the same data, but visualized as different designs. Humans are sensitive to those, and they draw different conclusions from these different designs. But LLMs, they do not treat them sensitive. They do not treat them in any different way. Even if we input codes that specify a different design, where we show them images alongside code that clearly has a different design, they don't care. They treat these designs all the same, or not all the same, but they don't have the same degree of sensitivity that humans do. What they are sensitive to is something that humans are less so. So humans tend to care more. Humans don't really care when it comes to visually perceiving information as much when the data's context change as much. So in these 2 visualizations, they're the same data set, but one is labeled to be about companies and revenue, and one is labeled to be about vehicle and durability, but it doesn't change what your visual system is going to take away from the visualization. You're going to see the same pattern that's, okay, this one is like a hat shape, and this one's like a bowl shape. You see that in both of these cases, whereas for an LLM, they don't, right? They're like, okay, one is about vehicle, one is about company, so the conclusion I draw for the vehicle one must be different from the conclusion I draw from the company one. They're sensitive to a different type of thing. So what I'm trying to say with this, if you want to read more about in the paper, is that we need to be conscientious of when we use models to emulate humans, we seem to care about different things. And given that design has such a profound impact on human decisions and interpretation of data, we need to be even more cautious when we use large language models or any model to support that process of design and predicting what humans will do. Right, so more work is needed here towards this grand goal of understanding the downward stream impact of design on visualizations. And you can also imagine we can reverse this process, right? We can take some human takeaways, natural language utterances, and we can feed it into the model. We can say, can you generate a visualization that will help people see this takeaway that I want people to see? So this is very much like you trying to communicate a visual story, or you trying to analyze or explore some data in your research project, or for your as a consulting gig for your government agency. And the ideal outcome might look something like this, right? You ask your computer, can you build a visualization that helps people see that people are increasingly relying on the internet to get their news? and your computer says, how's this beautifully done visualization, right? So we haven't gotten there yet, but there are some progress that we have made, and I'm sure Leo has some very fancy tools these days that can do very close to this. We are working with collaborators from Tableau, and this is their Ask Data interface. And what it does is that you type in a natural language query, and the interface will answer your query, which is compare the user ratings of these two books through a visualization, right? So we are building towards this goal of allowing visual expressions. We're allowing users to input verbal expressions, and we visualize it for you. That it answers your question, it emphasizes a point. However, this is still at a very preliminary stage, I would call it, because we run into two grand challenges. And I think of these two grand challenges as kind of the driving force behind my group's research. The first one is that the patterns that people see in a visualization is very difficult to predict. And the second challenge is that the language can be very ambiguous, and they can make interpretation difficult. So I'll tell you about some of our journeys trying to tackle these challenges. These problems are not solved, but so we're getting there. And if you can, we can join forces to solve them through after me hearing about me ranting about all the issues we run into. I think that would mean a lot to me. Okay. So when it comes to the first challenge, what people perceive in a visualization is hard to predict. So if we want to build a model that can predict human behavior, if this is very difficult, then how do we do it, right? I have a demo to kind of give you a sense of what I mean by it's hard to predict human takeaway. So this is a fun one. Let's say we have two student government parties on campus running for office here, and you have their voting results for year 1 to 3. The y-axis shows percentage support they have received, and there are two parties, the blue party and the green party. My ask for you is, who do you think is going to win in year 4, blue or green? Green. That's right, green's on an upward trend. But there is no real answer here, right? So I'm sure there are some blue supporters in here as well. I do see green as the increasing trend of gaining momentum, but some of you might also see the fact that so besides green gaining momentum and shortening the gap between itself and blue, some of you might be thinking, well, blue won every single year. Why wouldn't it win this year again, right? If you look at the most recent year, blue won again. So why wouldn't blue win in year 4? Right, so we throw this chart in front of people on the internet and we ask them, who do you think is going to win? And you see this very nice bimodal distribution here, where half of the people sees green and the other half sees blue. Right, so this just shows that we can't rely, just looking at the same visualization, people just naturally will see different things. And there is no good predictor of whether, do I know if Joe is going to be a green person or a blue person? I can't predict that. And so, but what I can predict is how people might react differently when I change up the visualization design. So I took the visualization and I changed. So the bar chart, I made it up. There's no real answer here, right? This is just a demonstration. There's no real winner here. But I took the same 6 data points in that bar chart and I converted it into a table. And then now I threw the same table on the internet and I asked a different group of people, who do you think is going to win? They're saying blue, aren't they? They're saying blue now. Nobody supports green because the upward trend in green is no longer salient, right? So you see, just simple manipulations to how you communicate the data can really change downward stream impact of what people do. So this is what I mean when I say what patterns we'll perceive in data is hard to predict, but we can generate predictive models by understanding how design influences perception, and we can make predictions that are much more reliable. And so this is what I was trying to conclude here. Two people looking at the same visualization, depending on what they see, they can draw different conclusions. So I draw this connection to the literature in psychology, where in psychology, they have these things, these objects called ambiguous figures, things like this. When I show you this, what do you see here? This little guy. It's either a duck or a rabbit, right? So visualizations are essentially a similar type of construct, right? You can think about visualizations as that ambiguous thing in the middle, but some people will look at it and say it's a duck, and some people will look at it and say it's a rabbit. And coming back to here, I want to make one more point since I live in Georgia and it's a very contended state right now given the current election situation. And what's happening right now is that a lot of data platforms are putting out visualizations and trying to help people form opinions about what they should do in this coming election. And a lot of them don't they often show you these unannotated version of the visualization, this clean version of the visualization, but sometimes they add annotations to it to help you see certain patterns more vividly. For example, in this scenario, I can highlight and box the blue bars to bring your attention to the fact that blue has been winning every year. Every year it has beaten green, sometimes by a little bit, but it has beaten green every year. Alternatively, I could have done something like this where I highlight the green and I say, look at this really salient increasing pattern of the green. We totally get it. We'll totally get it this year. Yeah, so please vote for green, right? So you can see these different visual annotation techniques will have different downstream impact on people's decisions. And so we threw these bottom two versions in front of people, a different group of people. We asked them the same question, like, who do you support? Who do you think is going to win in year 4? And here is on the top, I'm going to compare the outcome of the bottom two to the one that you're already seeing, where it's the clean version where people are evenly divided. So half of them are green supporters and the other half are blue supporters. And if you look at the binary counts, you'll see that there is about even divide between blue supporters and green supporters. So here's the data for the bottom two. I'm just going to show it to you and we can stare at it for a little bit. Right? And suddenly what you're seeing here is that when you tell people, look at how well blue has done every year, people are like, oh yeah, I can see blue winning. Or you can tell people, hey, look how much green is gaining momentum. They'll say, oh, I see the green is gonna win and has a lot of momentum and upward trajectory, right? So this annotation is changing what people's decisions are for this simple data set. And we then wondered, like, okay, so does it mean that we can just, is it because like when you tell people something, they just think that's what should happen simply because you tell them? Are there different kind of classes of ways of telling people that such that some are more effective than other types, right? So we looked at the way that we annotated this and we call these annotations things that you add to a visualization. But in contrast, a lot of times what you see on these big data platforms like New York Times is that they use these other techniques, which we call visual highlighting. Visual highlighting, instead of adding things, we manipulate the color saliency and intensity to make certain colors in the visualization stand out a little bit more. And we wonder if these styles will also have an effect on people's downward decisions on this visualization. And this might be a little difficult to see for folks at the back, but this is the distribution associated with this chart, and this is the distribution associated with this chart. And what you're seeing here might be easier if I show you the binary version of people's count, is that visual highlighting actually doesn't have as much impact on people's decisions as visual annotation. So I'm going to take this one as an example since it's easier to reach for me. When you highlight the green bars to be dark green so that people will definitely see it, and then you fade out the blue bars to be light gray, people didn't care. There are still blue supporters and green supporters evenly split, about 50-50. And to contrast that with highlighting the upward trend here with this arrow, most people are green supporters here. So what this is telling us is that this annotation technique seems to have a stronger power in terms of swaying people's conclusion towards those annotated patterns. But highlighting them does not seem to actually impact people's decisions. And we even changed the color scheme here to be red and gray, and it's the same outcome. People are not swayed by changing colors to things, right? So it also seems that it's not a simple story of just annotating and using visual manipulations to get people to see what you want to see. It's not always about that, right? People are not always sensitive to that. But when you annotate, people are like, oh my gosh, I need to go with what you're saying. But when you use this visual highlighting, not necessarily. Right, so the takeaway here really is that visual annotation can change what people see, but not all annotations are created equal. So we need to understand what the downward stream impact of these annotations might be. So when we leverage them in our own visualizations, we can do so effectively. Is that a question or okay? All right. And the last thing I want to say is that visual feature matters, but people also draw conclusions because of their motivation, their experience, and their background knowledge, right? Like imagine I'm like a person who believes in underdogs because my university really sucks at football. So I want to see increasing, is Maryland? We're not good at So y'all with me here. So if you tend to believe in the underdog, so maybe you're more likely to see increasing patterns that's more salient, and you want to see that green would win in this election, right? So there are these individual differences that have really not been modeled well in our current state of art. So I think with the introduction of large language models or just big data, we're going to be able to model these more effectively to understand how different people might be impacted by design. Okay, so coming back here, so if we want to build this model to predict what people take away from a visualization, we have to figure out what people see in a visualization first, and that is very difficult. But let's just say we even accounting for what they see, if you want to interact with people, you have to communicate with them. And when you communicate with them, you need language. And language is just as visual, very difficult when you start working with them at a fine level. This language can be ambiguous, and making interpretations of language or utterances can be challenging. And so I have a demo for you here. So when we do this kind of work, I want to say how we're able to get people's conclusions from visualizations is me asking them on the internet, and then I stare at their response and I try to make sense of them by like categorizing them through like these top-down or ground-up analysis techniques like thematic analysis or whatnot, right? It's me and my grad students in a dark room for multiple hours and multiple weeks, and we sift through thousands and thousands of responses. And to give you a taste of what we did, right? Here is a very simple visualization. It shows the score that two papers have received by two reviewers. There's paper A and paper B, reviewer 1 and reviewer 2. And one participant looking at this might say things like, paper A received a higher score from reviewer 1 and reviewer 2. So there's you can probably think of one way to interpret this. And in the beginning, to me, it was pretty obvious. There was one interpretation until me and my students looked at this and realized that we coded them as different interpretations because the language, this description is ambiguous. So what are some potential ways of interpreting this? You probably have some idea in your head. I'll offer you two ways, and hopefully you don't generate more because I cannot think of more ways that this could be ambiguous, but let's see which one you map onto, right? So one interpretation of this is that paper A received a higher summary score from the combination of reviewer 1 and reviewer 2. So what this person might be thinking is that the sum of the two white bars is greater than the sum of the two gray bars, okay? But alternatively, they might not be computing sums in their head. What they might be thinking is, looking at this reviewer 1, paper A wins. Looking at this reviewer 2, paper A also wins, right? So paper A won twice, as opposed to paper A won once in this case, right? And in our heads, like cognitively speaking, these two are very different manipulations. It might not feel so when you only have two bars, but imagine there's a third bar, right? Maybe paper A didn't win in the third bar, but the sum of paper A still wins, right? So there are two different ways you can interpret this written sentence. And it's really tricky for us to start building a model that can predict human takeaways, because all the qualitative coding of us making sense of human takeaway involves a lot of these trying to disambiguate what a human is saying. And let's say we got enough people to annotate these linguistic outcomes. We generate enough insights that allows us to quickly predict and understand what people are saying. When you throw this model in front of visualization, when we implement a natural language tool like this, the users are going to have to input some queries. And that query they input can still be very difficult to understand. So I don't know if some of you have worked in industry before. Let's say your manager tells you, I want to go open a hot dog stand and sell hot dogs, right? And like, that's pretty easy. I can make a chart of all the potential requirements people might have in terms of hot dogs. I'll prepare all these sauces and all these like takeaway boxes for hot dogs. And then you go and you start your hot dog stand. And on day one, someone comes to you and says, can I have a burger? It's not something that you prefer, you were ready for, right? You're ready to sell hot dogs, but you did not prepare anything in the burger realm. So as you cannot control what your users are gonna come to you and ask for. And what they might end up doing is that they might try to interact with your program, your system, your model in very vague language that you have not accounted for beforehand. So to give you a very simple example here, right? Let's say we have a very small data set with 4 attributes only. This is a data set about movies. So this one has movie name, its box office, user ratings, and movie length. And then you have this really cute natural language-based data interface here that allows users to ask you any questions about your data set, and then you will return an answer to them based on your available information. So the user comes in and then they ask you, can you compare the popularity of movie A and B? You can probably do it, but you don't know what they mean by popularity specifically, right? They could mean box office, that is a measure of popularity. They could mean some combination between box office and user ratings, but you don't know if they would weigh them 50-50 in their head, or maybe it's all box office and very little user rating, right? So that ambiguity in their sentence, in their utterance, is something that you need to formalize in the back end. And without understanding what might be a good formalization of it, it's tricky to implement this in your model. And even if they ask you things like compare the popularity of long movies, you have a variable that is about movie length. So technically you could compute the long movies, but yet you still don't know what might be considered long movies in this scenario, right? Long movies could mean like longer than average or top 10 percentile or anything longer than an hour, because we don't have patience for movies these days anymore. Right? So this example is really showing us that users can bring a lot of vagueness in their linguistic description, and that needs to be accounted for when you build a program like this. And so what we're trying to do is we're trying to resolve ambiguity by showing people visualizations, which is also ambiguous, and just let the ambiguity kind of account for itself. So what we did is we interviewed a bunch of Tableau users, and then we asked them what they would do when they encounter, like imagine you're a computer, what would you do if you encounter these really vague user requests in natural language? And then they would generate visualizations that would answer the question, because humans are pretty good at making inferences, and we're pretty good at generalizing and giving people like, I think this is what you mean, it's probably good enough. And then we try to formalize this into a code that basically can answer and tackle these ambiguous descriptions and give people a good enough answer to kind of jumpstart their visual analytics or their analysis of the data. So to kind of give you a feel of if you were the participant in the evaluation phase of this project, right? What you would see is you would see this command of this user input. Let's say is to compare a highly rated book with a similarly highly rated book with respect to price. And then we have all these potential recommendations, and you would rate which recommendation you think would be the best for a human user. So maybe I'll show you a scatter plot that shows price and reviews for a bunch of books, or maybe I'll show you a dot plot that just shows you the price, and then I randomly select a highly rated book based on some internal definition, and I highlight it in the dot plot. Or I can just show you this randomly selected book and then compare it to other books that I think of as similar. Or I can show you a bunch of different books, and then I'll tell you this one is about this expensive, and these are books with similar ratings. You can compare their price, right? So there are many ways I can kind of create a visualization that can answer that. So we threw all these potential recommendations in front of human judges, and then we asked them, which one do you think is the best? Like rank these, right? So let's see if our research is actually valid and replicable. So which one of these four do you think humans ranked the top highest to be the most effective as an answer to the question, compare a highly rated book with a similarly highly rated book with respect to price, which is shown on the x-axis for each of all of them. Yeah, I won't put anyone on the spot, but think of one in your head, okay? You got one? And this is the one that people generally found voted to be the highest. And then what we did in this paper subsequently, I won't bore you with the details, is we try to kind of formalize this, and we incorporate this algorithm of mapping this vagueness in verbal command to this visualization in the backend of Tableau's Ask data. Okay, so coming back to this, so all these examples is just showing you language, also ambiguous and difficult to deal with when we want to account for this model that's able to take verbal inputs and output predictions of or visualizations or predictions of human takeaways. And these two added together, hopefully I've convinced you that even though large language models are very powerful, we're not there yet, right? We're not able to quite understand how visualizations impact people, and we're not there yet quite in terms of designing visualization tools that can predict human takeaways perfectly and build visualizations that aligns with the human intents perfectly. So lots of work to be done, and I'm very excited to complain about these problems with you today. And I'm gonna, for the remaining 10 minutes or so, I wanna share something that's more real world relevant to you, to just give you a sense of how does this matter, how might this matter in our lives, in the real world. And the takeaway here would be that the visualization design that I showed you might seem really small, and then the conclusions that people come up with might be a little artificial, but this is a real problem in the real world. Okay, and they have implications for policy and for technology design, and I'll just give you two examples here, one from the criminal legal reform domain and one from just machine learning in the financial investment domain. Okay, so start with the criminal legal reform. I'm not a lawyer, but I do have some collaborators who are lawyers, and we started doing this project about trust and visualization in the criminal legal domain. And to give you my quick 2-minute summary of law, and what I learned is that the US criminal legal system is very complex. That's the first thing I learned. The second thing I learned is that there's a lot of potential discrimination or biases that could happen in the legal process, because legal professionals make a lot of decisions every day. And the complexity and opaqueness of the system hides a lot of these potential biases and issues in their decision pipeline. And so here's a visualization of their decision pipeline. I don't expect anyone, including myself, to get anything out of this. Besides, this is very overwhelming. So you have some crime, and from this crime to go all the way to be resolved, you have a series of decisions that people have to make. And again, I don't think we need to get anything from this besides that this is a very overwhelming system. Okay, and because of this, there's increasing demand for change. And district attorneys and prosecutors, they play a major role in pushing for change. And the primary kind of goal they have is to push for change through data transparency and dissemination. And they call themselves progressive prosecutors. And when it comes to data transparency and data dissemination, if you were to operationalize this in my world, I think of them as online data dashboards. And this is a common practice that district attorneys have been using to disseminate and publish their work so that more people are aware of what is going on in the criminal legal system. So what do these online data dashboards look like? So here's one from Multnomah County. You can see, just get a sense of the different designs, right? They have maybe total case number or victims and defendants, and they have some examples and definitions. So this is how Multnomah County chose to, this is in Oregon, chose to express this information. To give you a different style, this is Lake County in Illinois. And you see, they took a very different approach. There's barely any words. You just see two visualizations, and they talk about different cases, type of cases, and they look at different felony by race. This is on their front page. You click into it. This is the first thing you see back in 2021. And there's a different design here by Yolo County. This is California, and they did a more of integration of visual and text, right? So there are these little stories almost that you can read about what it's about, and then a little chart next to it to give you a sense of the data associated with that little story. So just as a case study here for y'all today, you can see that there are very different approaches that people took to design this data dashboard, and this is by district attorney's office. And so you can ask the question of how does sharing criminal legal data using different dashboards influence people's understanding and subsequent trust in the legal system? And we can ask them, we can show people who are looking at these dashboards very simple questions like, looking at this, how much do you approve your local district attorney's work? How much do you understand the information? And how much do you trust the data and trust your local legal system? And this is generally what people said, right? And then these people are not necessarily people from the county, but they're people from all over the United States. And this is, we try to recruit a balanced number of Republicans and Democrats and people with different ideology. And what you're seeing here is that, people understand the information better in that Yolo County design, where there's a combination of text and information, and they actually report to trust the district attorneys more because the design seems to be more clear. Now, this is all correlational data. I don't want to strongly make causal connections to it. So this is something for y'all to think about with me together. But design of visualization dashboard seems to matter. So there's more work that we need to do to understand why it matters beyond this correlational observation that I shared with you today. Maybe I'll quickly go through the second example, thank you, of how visualization design might also play a role in financial decision making. So I don't know if you all go to the bank, but I went to the bank trying to get a savings account, and then they showed me all these pretty cool visualizations and explanations of how they will handle my money. And I was just thinking, I wonder if the way that you show this visualization actually changes how people decide that you should save their money. Do they go more aggressive or do they go more conservative? And to kind of scope the problem a little bit. So we did a case study here, and we wanted to look at just from an investment advisor's perspective, how might visualization change people's investment behavior? And so let's imagine you have some money that you like to invest. Okay, and you look for a financial advisor to invest your money for you. And these days, leading firms have these we call robo-advisors. They're really machine learning algorithms that is kind of supervised by a smart person on Wall Street. But at the end of the day, they're machine learning algorithms. So we're going to call them robots. Okay, and you look at these little robots. Also, we manipulated number here a little bit so that it's more easy to talk about. Then you have these two robo-advisors. One of them will give you 70% profit, and the other one will only give you 50% profit. Here's an easy-ish question, I hope. Which robo-advisor would you choose? It's not a trick question. I'm guessing 70%, right? Okay, so we'll all choose the 70%. Because we get more money, that makes sense. But what if I told you that this 70% robo-advisor is also sexist? So there's research, right? a lot of research showing that this does happen in a lot of financial data because the data that are used to train this model may have some implicit bias. So this is not news to us. So, and these machine learning models they use in high impact domains might give people a sense that they are bias free, but that's not the case, right? They have discrimination problems, and we are aware of this. And people in the real world are working to solve this, which is really great, but they can exhibit bias. So how might people make a decision when they are confronted with this dilemma of, do I invest my money to get more returns, potentially with a racist or a sexist machine learning algorithm, right? At this point, who do you choose? You don't know anymore. Do I focus on the profit or do I focus on the sexism, right? But what if instead of just telling that to you using words, I ask you to make that decision while looking at some kind of visualization, right? So does communicating this information and asking people to make trade-offs, does people's threshold for what is okay change depending on what you're showing them, how you're communicating your information to them? So let's say, so we did a study on this and we showed people, well, here's some information about two investors. For every $1 you receive, on average, the investor will send back some money. So for this investor, investor A, if you're a man, the investor, for every dollar you invest, the robot investor will get you $1.50 back. But if you're a woman, for every dollar you invest, the investor will get you $1.90 back. Oh my gosh. And then for this model, it doesn't matter if you're a man or a woman. The robots will get you $1.50 back for every dollar you invest. Okay, so you can kind of see that this is kind of how we operationalize a potentially sexist investment robot. Okay. And we can also share the same information using just plain text, right? For every $1, they'll send this much to men and this much to a woman, depending on what gender you have. Okay, so these are these two conditions that we tested. And here's the result of people. So I'm going to walk you through this psychometric chart here. So on the y-axis, you have the percentage of people who chose the FAIR model. So by the FAIR model, I mean this model where, I think I might have flipped things on the side, but the model that sends the same amount of money to both men and women. We call this the FAIR model. And we call this one where it sends women more money, the sexist model, okay? So on the y-axis, you have the number of times the participant will choose the FAIR model. So if it's 100%, it means that they will always go for the FAIR model. If it's 0, it means that they will always go for the sexist model, okay? And on the x-axis, you have how much the machine is biased. So you can imagine, if the machine is not at all, if the machine is not biased at all, then there's no difference choosing between the sexist versus not sexist model. You choose the model that makes you more money. But the machine is super biased. Our conscious will tell us, maybe not this one, right? But there's going to be some medium spot in the middle where it's sexist, but it's not sexist enough for me to give away my $1.90 profits. And I'm okay with maybe buying a little bit into sexism to earn a little bit more money. At some point, that threshold changes for people. And what you're seeing here in the data is that when you show people the information using just text, that threshold for how much sexism they can tolerate is lower. But when you show that information to people using a bar chart, the threshold of how much sexism people can tolerate is higher. So it takes bar charts, the information communicated via bar charts, more discrimination for people to realize this is not okay. Right? So people were more likely to choose the FAIR model in the text version compared to the bar version. And so they care more about fairness when the information was presented in a text. I want to look into why that happened. So when you have a visualization like this and you ask them, why did they choose this model?
And different people use different strategies. Some people compare the amount of difference between the bars, and they're like, okay, I'll make more money in that model because that bar is taller. And some people used what we call self-profit. They look for their own gender, like, okay, I'm a woman, I'm gonna look for the amount of money woman makes. Am I okay with this amount of money? Sure. Then that's the self-profit strategy. Some people did this average strategy where they're like, I'm just going to turn a blind eye to the sexism thing. I'm just going to look at how much money this model will make us on average. I'm going to go with that one because I care more about the overall model performance. Or sometimes I use personal beliefs like I will never choose the sexist model ever, and they'll just go with the more fair model. So there are different strategies. And these two are actually the most prominent. And what you're seeing here is that people tend to do that delta strategy more often when they're confronted with text. And when they are looking at bar charts, they're more likely to look for the biggest bar and to see, is that my gender or not? And then what also happened is that when people use that delta strategy to notice the difference in profit, they are more likely to choose the fair model. Whereas when they're looking at their own profit, they're more likely to choose the bias model because they'll always choose the one that makes themselves more money. And also just interesting, not by no means causal, but women tend to use the delta strategy more, whereas women and men tend to use the self-profit strategy equally. So if you look at the distribution, this is like a 50-50 divide in terms of men and women, and that's more women leaning. We also interviewed a bunch of non-binary folks, but then there are just not that many in the current platform that we use. So we have not enough data for me to even show you like generalizable conclusions, but we are doing a subsequent study with only non-binary participants so that in maybe a year's time, I will, if you invite me back, I'll give you the sequel to this where non-binary folks data is included. If you want to read more, of course, this is all in the paper. All right, so just quickly summarize. Design impacts trust and decisions in the real world for policy and for technology design. And we talked about these two domains. And overall, all in all, what we want to think about is just how visualization design impacts decisions that people make. And I need y'all's help to solve the challenge of predicting what people see in a visualization with me and to figure out how we can use natural language more effectively in the tools that we build because of this real world component that we must account for. And if you are going to take anything away with you today is that if you are designing visualizations, please do so thoughtfully. And thank you. Thank you. And thank everyone for listening and thank all these people for their support. Happy to take questions.